Welcome back to another metrology and measurements session. Today we are going to discuss about the second unit, measurement of linear angular dimensions, assembly and transmission elements. My name is P.Navin Jass, Assistant Professor, Department of Mechanical Engineering, Rohini College of Engineering and Technology.
This is the second session of this linear and angular measurements course. In linear and angular measurements, already we discussed about vernier caliper and its types, vernier depth gauge and vernier height gauge. Today, we are going to discuss about the micrometer and its types. Micrometer. What is meant by micrometer? It is a precise instrument which is used to measure a job with an accuracy of 0.01 mm. It is used to check the outside measurements are known as outside micrometer. So this micrometer is used to measure the outside measurements. Most of the micrometers are used to measure the outside measurements, and it is the different micrometers are used to measure different purposes. So what are the main parts of the micrometer? Here, this is a frame, anvil and spindle, graduated sleeve or barrel, thimble scale, ratchet or friction stop. So here, what is the use of the frame? So this is the frame. It is made to required shape, but at the same time, it should be in such a way to permit the part to be measured. It should be rigid to carry nearly 1 kilogram of the part. Frames are made of using light alloys for large micrometers, but small micrometers they are made using steel, cast steel and malleable cast iron. These are the materials which are used to make the frame of a micrometer. For large micrometers we are using light alloys, and for small micrometers we are using cast steel or malleable cast iron. Then the second one is anvil and spindle. First we are going to see about the anvil. What is the use of the anvil and where it is placed? The fixed anvil of the micrometer protrudes for 3 mm from frame to support the part at one end. This anvil is fixed at the frame at one end, and from the frame it is enlarged or protrudes 3 mm from the frame to support the part at one end. This is the work of the anvil. It should be strong enough to reduce wear and tear. This anvil should be strong enough to reduce the wear and tear, and the face of the anvil is sometimes chipped with tungsten carbide. The faces should be ground and lapped to ensure the flat and parallel surfaces. So this is the thing about the anvil. And now we are going to see what is the spindle and what is the use of the spindle. From this diagram, animated diagram, we know what is the use of the spindle. It is placed inside the barrel. This spindle is placed inside the barrel to slide freely forward and reverse. Forward and reverse. A bush is placed in the space between barrel and spindle to ensure free running of the spindle. The face of the spindle should be ground and lapped to obtain the flat and parallel surface, because this face also touches the part one side while measuring. And when the spindle is far away from the fixed anvil, the micrometer will show the maximum reading. The movement of the spindle is locked by a locked nut. From the figure we can see the lock nut. The outer periphery of the lock nut is knurled to get the sufficient grip while measuring. So this is the use of the spindle in the micrometer. This spindle is placed inside the barrel. It has a place inside the barrel and it moves freely through the barrel forward and reverse, and it is gripped between the barrel. Then the next one is graduated sleeve or barrel. These graduations are made on both barrel and thimble. These parts are made by using high wear resistant material. Barrel and thimble are made of high wear resistant material. This thimble is over the sleeve. This thimble is over the sleeve. It has an vernier scale readings. The main scale readings is on the sleeve. The main scale readings is on the sleeve. Both are graduated to get the real value of an object. So here in the thimble there's some vernier scale readings, and the sleeve there's some main scale readings. It moves over the main scale, which we call it as a graduated sleeve. This graduated thimble is moves over the main scale uh, for the purpose of to find out the measurements. According to the job, the spindle moves forward and reverse. The spindle moves forward and reverse. The thimble also moves forward and reverse according to the object's dimension. The next one is ratchet or friction stop. Ratchet or friction stop. This ratchet driver or ratchet or friction stop, which is used as a wear resistant material to make a ratchet. This is the thing, the operator which moves forward and reverse the spindle with the help of this ratchet. According to the need, this ratchet is frictionally stopped. When the friction gets clear with the spindle, it automatically, the friction which is on the spindle, we can sense with the help of this ratchet, we can able to stop the movement of the spindle with the help of this ratchet. And that's an adjusting nut. It is used to get zero readings. The adjustment is done by using spanners and keys. The accuracy of measurement mainly depends on the original accuracy and function of a lock nut. This lock nut, which is used to lock the entire assembly movement to find out the precise readings. Then, what are the types of micrometer? Here, first one is outside micrometer, second one inside micrometer, third one micrometer depth gauge, fourth one thread micrometer, fifth one micrometer for measuring thickness for cylindrical valves, dial micrometer, and digital micrometer. Okay, first we are going to see about the inside micrometer. We already saw the outside micrometer. This is the inside micrometer. It is used to measure the internal dimensions. From the figure itself, we know it has a carbide jaws, sleeves, thimble, ratchet stop, locking nut, and spindle. All the things are similar to the outside micrometer, but there's an additional setup. We have the carbide jaws to get the internal dimensions. Then next one is micrometer depth gauge. It is mainly used to measure the depth of holes, slots, and recesses. It has one shoulder acting as reference surface. It will slide up and down during the measurement. It is held tightly perpendicular to the axis of the hole. The maximum range of depth micrometer is 0 to 0.225 mm. Here in depth micrometer, the different parts are, there's a face of the spindle, and that's a spindle. This is the face of the spindle, and this is the spindle. There's a sleeve, thimble, ratchet stop. This is the object. The brown color which shows the object. We are going to measure the depth of this object. So for that purpose, we are moving the spindle inside the object, and here we are going to measure the movement of the spindle, we can able to uh, get the graduator scale readings with the help of this graduator sleeve and thimble. Then the next one is thread micrometer. It is used to measure the pitch of the threads or pitch diameter of the threads. The given micrometer is required to measure the range of threads of different pitches. A small error can rise because of angle settings in this thread micrometer. The pitch diameter is first measured for a standard plug gauge of the same size as the thread to be measured, and then it is compensated for the error. The thread micrometer has special contacts to suit the end screw thread to be checked. The end of the spindle is pointed to a V thread formed with the corresponding V recess in the fixed anvil. When measuring the thread, the angle of point and flanks of the thread only come into the contact. If correctly adjusting the contacts means the micrometer will give the pitch diameter. The main advantages of this thread micrometer is one and only method to show the variation in a drunken thread. What are the limitations? So the limitations of this thread micrometer, it must be set to a standard thread plug. When setting the standard plug gauge, the thread is not exactly to 0. Then next one is micrometer for measuring thickness of cylindrical walls. The ordinary micrometer cannot be used for measuring the wall thickness of a tube, sleeve or bush because of the concavity of the internal surface. So the micrometer thickness gauge is used to avoid the inconvenience. The fixed anvil of a thickness micrometer is in a spherical form. The frame is cut away on the outside to permit of the anvil being introduced into tubes of diameters as small as 7.5 mm. In the anvil, it is made in a cylindrical form and its axis is being perpendicular to the axis of the spindle. Then the next one is a dial micrometer. That's an additional setup here placed is a dial gauge. A dial indicator is connected with the movable anvil as we saw in the figure. The slight movement of the anvil is directly indicated on the dial of the dial indicator, which is fixed into the frame. The 0 value is set on the dial indicator by butting both the ends of the micrometer. The type of micrometer is very much useful for statistical quality work for different size variation. So finally, the today's session is over. Thank you